Hey guys, congratulations on finishing your quiz, but now we're going to learn about linear and nonlinear functions. Yes, we can have functions that are linear and nonlinear. Do you remember this from last year? What word do you see in linear? Hopefully you remember you see line. So linears are straight lines. Nonlinears would be anything else that's not straight, nonlinear. Today we're going to explore what it looks like in equations, graphs, and tables. Graphs you probably already know, but these two will probably be a little different for you. All right, let's go ahead and give it a start right up here at equations. First and foremost, what you need to remember is that a function is considered linear, aka it creates a straight line if it has a constant rate of change. Do you guys remember what that constant rate of change is called from last year? I'm hoping you remember a little something about it, or at least the fact that it exists. I'll take that. I'll take the fact that it's an existing thing that you should know, but could know, and if you don't know it, you're going to know it now. Okay, so something is linear if it creates a straight, non-vertical line. So that means it can't go, well, non-vertical, it doesn't really matter, but it's got to be straight. Okay, let's look at equations. Our hint here says, can be written as y equals mx plus b. I know I'm extremely hopeful, but I'm hoping you remember that from last year. Which one of these would be in the form of y equals mx plus b? Think about it. Which one? Okay. Hopefully you recognize that this x is an x to the first, or it's just an x that stands alone. But this one is to the second power. So this is a no-go, which means it's not linear or non-linear. Over here, we have an x that is to the invisible first power, or just a 3x, and notice that this exactly matches. Y equals 3x plus 4. Y equals mx plus b. So this one is indeed linear. All right, let's open up our flat and take a look at our examples. So basically, what you're doing when you're asked if an equation is linear or nonlinear is you're looking for an x that is always raised to the first power. What that means is you just have an x that looks like that. It can't look like this. That is a no-go. You can't have one that looks like this. That is a no-go. You can only have ones that look like this. Now, it could be another variable. It could be like m. So m is okay, but m to the second, that's a no-go. Does not belong. All right, let's take a practice. Look at this first equation here. Does this x look like those x's? I'm hoping you say no, because it's got a 2. That 2 immediately tells us that this is non-linear. Means it will not create a straight line if we were to graph it. And it doesn't increase or decrease at a constant rate of change. Now this one's tricking you. It's saying, hey, this x looks like it, so yeah, I'm good to go, but not so much. Notice here, these are operations happening to our x values, to our variable. A square root is an operation, so this one is also non-linear. The variable cannot be inside of any operations like squaring a number, square rooting a number, cubing a number, cube rooting, anything like that. Let's come to this one. Uh-oh, this was hard to tell because it's not simplified, so let's go ahead and simplify it first. So we need to distribute our 6 to both pieces, and we get y equals 6x minus 18. What do you think now? You're right. It is indeed linear. Sorry, my pen is terrible right now. Good. Last but not least, this one also, you're probably thinking to yourself, well, duh, the x is by itself. But were any of these in the bottom of a fraction? Any of the ones that worked? No, and the reason for that is that if we were to rewrite this as an exponent, it would be y equals 2x to the negative first. Now, I know you don't know why that is yet, but just know that it is. So if you're in the denominator, it's a no-go. You are nonlinear. So basically, there is just one situation where you are linear. It's when your x stands alone. You may have to distribute, but that's what it is. Equations, I think, are one of the easier ones because all you have to do is look and see if your x is by itself And if it is, you're good to go. All right, let's take a look at graphs. If you were to think which one was linear, would it be the first one or the second one? Hopefully you said the first one. This one is indeed linear because it creates a straight line and has a constant rate of change. This one is very obviously non-linear because it's got a curve. Non-linear. Good. All right, let's open up our flap. Now I want you to try and identify which ones are linear and which ones are not. Go. Hopefully you said this one was non-linear. Hopefully you said that this one was indeed linear and this one was non-linear. Now notice this one has two straight lines, but that's the problem. They don't make one straight continuous line like this. So this is non-linear. I hope that didn't trick you. Cool. Close your flap. Let's look at tables. This is probably the trickiest one, I think, because you actually have to do some math. But what you're looking for is you're looking at a constant rate of change using addition and subtraction. So we're looking for adding and subtracting patterns. Remember when we used to do this last year? You remember that? We used to go from one to the next to the next. Well, we're doing it again. 4 plus what gets us to 7? Well, 4 plus 3. 7 plus what gets us to 10? Plus 3. 40 plus what gets us to 36? Well, in this case, I hope you notice it's not a plus, but indeed it's a minus. So 40 minus 4 is 36. 36 minus 4 is 32. Do we have a constant rate of change? Well, yeah, we do, because we did plus 3 each time, we did minus 4 each time, so check. This one would indeed be linear, and the reason is because, we'll put B/C, it has a constant rate of change. Good. Now let's check our other table. 1 plus what gets us to 2? Plus 1. 2 plus what gets us to 3? Plus 1. Now here we got 2 goes to 4 by adding 2, but 4 goes to 8 by adding 4. Do you think that's linear or non-linear? Hopefully you said it's not linear because it doesn't have a constant rate of change. Notice here we go plus 2 plus 4. That's a no-go. It would have to be the same in both sections. All right, open this flap up and let's put it to practice. Remember, we are only looking for addition and subtraction patterns. Okay, let's draw our arrows. -2 plus what gets us to 1? Plus 3. 1 plus what gets us to 4? Plus 3, plus 3. On the bottom, check your patterns. You try it before I do. Hopefully, you saw it was plus 5, plus 5, plus 5. So what do you think? Is this linear or non-linear? It's linear. Good job. So it's linear. I'm going to use a different marker because I don't like that one. It's linear. And again, hold on. It's linear. And again, that's because it has a constant rate of change. The adding is consistent across the board. Good. Let's try this one. Can you guys try it ahead of me? Try to decide if it's linear or non-linear. Okay, I'm hoping that you saw this, that it was -1, -1, which means, okay, that side worked. But then here it's plus 7, plus 11, plus 13. That one doesn't work. So this is non-linear. All right, can you try the third one for us, please? Let me get this up there. Pause. Well, you don't have to pause it. It's going to pause itself. But try this one. Go. Okay, check your work. How did you guys do? Did you get it right? Did you get it wrong? What do you got going on? Let me know. All right, so you guys just learned what linear and nonlinear are in equations, graphs, and tables. What you're going to do now is you're going to go practice this skill in the GimKit posted Google Classroom. Thank you guys so much and have a nice day.